Welcome to the first lecture in the lecture series of Signals and Systems. In this lecture, I will introduce signals and systems, but first we will discuss the syllabus. The syllabus is broadly classified into 10 different parts. The first one is the introductional part, in which we have to deal with few basic definitions and classification of signals and systems. The second part is the basic operations on signals. In this part, we will perform basic operations like scaling, shifting, integration, differentiation, etc. In the third part, we need to learn the basic system properties like static, dynamic, causal, non-causal, etc. The fourth part is the time domain analysis of continuous and discrete time systems. The fifth part is the Fourier series analysis of continuous time signals and discrete time signals. CTS stands for continuous time signals and DTS stands for discrete time signals. The sixth part is the Fourier transform analysis of continuous time signals and discrete time signals. The seventh part is the Laplace transform. The eighth part is the Z transform or Z transform. The ninth part is the sampling theorem, and the last part is the random signals and systems. So this is the syllabus, and we will try to complete this syllabus in the coming presentations. In this lecture, we will start with definition of signal. So what is a signal? A signal is a dependent variable, or we can say function of one or more independent variables. So signal is a function or dependent variable which depends on one or more independent variables, and let's say x1, x2 all the way to xn are the independent variables. So function f is a signal which depends on x1 to xn because they are the independent variables. Now we will talk about difference between signal and DC value. Any quantity is said to be a signal if it is varying with independent variable, and anything which is constant is not a signal. For example, the alternating current is a signal because the current is changing with change in time. The current is alternating with change in time in case of alternating current, so it is a signal. And if we talk about the direct current, it is not a signal because the current is constant, it is not changing with change in time, so it is not a signal. We are not getting any kind of signal, we are not getting any kind of indication in case of direct current because the current is constant. So this is the difference between signal and the quantities which are not a signal. Now we will move to the next part of this lecture, in which we will talk about two different types of signals. The first one is the single variable signal, single variable signal, and the second one is the multivariable signal. And as the name suggests, single variable signal is the signal which only depends on one variable, or we can say the function of only one variable, and the multivariable signal is the signal which depends on more than one variable. In this course, we have to deal with single variable signals only, so we will focus on single variable signal, and the example is like fx or gt. These are the examples of single variable signal. The examples of multivariable signals are f1, x1, x2 and g1, t1, t2, t3. This function depends on two variables x1 and x2, and this function here depends on three variables t1, t2 and t3, whereas function f depends on x only, and this function also depends only on one variable, which is time t. So this is all you need to know about the signals, the definition of signal, what is the difference between signal and DC values, and the classification of the signal based on number of variables. Now I will explain what do we mean by a system. The meaningful interconnection of physical devices and components is called as system. I will repeat the definition again. The meaningful interconnection of physical devices and components is called as system. System alone cannot achieve anything. Let's represent the system by this rectangular box. This is the system, and if we have a system alone, it cannot achieve anything. For example, let's say we want to fill the overhead tank with water using a pump. So pump is a system, but alone it will not be able to complete the task. So the system, which is the pump, must be linked to a signal. The system must be linked to a signal, and in this case signal is electricity. We need to provide the electricity to this pump so that it can pump the water to the overhead tank. After receiving this signal, the system must process this signal and produce another signal which is more desirable than the input signal. So this signal here is the input signal, and after receiving the input signal, the system must process this input signal to produce another signal. The output of this system is another signal, and we will call this signal the output signal. So this output signal is more desirable as compared to the input signal, and this pump is producing the output signal, which is the mechanical work, to pump this water here to this overhead tank. We need mechanical work. So this signal is much desirable as compared to electricity. The electricity cannot pump this water to this tank. We need mechanical work. So the pump receives the electricity, which is the input signal, and after processing it produces mechanical work, which is the output signal, and using the mechanical work we can fill the overhead tank. I want to make one thing very clear. Electricity is not always less desirable than the mechanical work. In this scenario, when we want to pump the water to the overhead tank, the mechanical work is more desirable as compared to the electricity, but in other cases, electricity may be more desirable as compared to the mechanical work. So the input signal and the output signal purely depends on the task we want to achieve. The output signal also depends on the same variables. For example, if the input signal is the function f and it depends on x1, x2, then the output signal, and let's say the output signal is the function g, it also depends on the same variables x1 and x2. There are two types of problems we have to deal with. The first one is the analysis problem. The second one is the synthesis problem. In case of analysis problem, we have the input signal. The input signal is there. We have the system. The system is there, and we have to find out the output signal. In other words, we can say we have the system, we have the input signal, and we need to find out the response of the system. This type of problems are most general type, and there is always a solution of this type of problem. On the other hand, in case of synthesis problems, we have the input signal, we do not have the system, we have the output signal, and by using the informations about the input signal and the output signal, we need to find out the system. Compared to analysis problem, this type of problems are complicated, and there may or may not be the solution of this type of problem, because the system may or may not exist for the given output signal. In this course, we have to learn different analysis techniques, and using them we will compute the response. So basically we have to deal with analysis problems, and this is all for this lecture. If you have any doubt, you may ask in the comment section. In the next lecture we will discuss continuous time signals and discrete time signals.